Alright, in this video we're going to talk about how to solve an exponential equation. Now, I did another video where we solved simple exponential equations where we can get both sides of the equation as the same base raised to a power, and then we just set the exponents equal to each other. These are the guidelines, these are the steps that we'll use when we don't have one of those simple types. Although, for even those simple types of exponential equations, if you use these guidelines, you can still solve those types and get the same answer, right? So these guidelines will work for every type of exponential equation. It's just if it's one of those simpler types, it's easier to do it the way I talked about on that other video. But if you don't recognize it or you forget how to do that, these steps will work every time. So make sure you know how to use these steps. Because like I mentioned on that other video, most exponential equations are not of that simple type. Alright, so here's what we do when we have an exponential equation and we need to solve. Now remember, exponential equation means your variable is in the exponent. Right? So like I've mentioned in some other videos that I've done, when you're solving equations, you have to use different methods depending on the type of equation you have. Right? If you have a linear equation where you just have an x to the first power, then you're just adding and subtracting stuff to the other side, you're combining like terms, you're dividing numbers over to get the x by itself. That's the methods you use for solving a linear equation. If you've got a quadratic equation with an x to the second power, well, now those linear methods don't work. Now you have to use factoring or the square root method or the quadratic formula to solve it, right? There's different methods for that different type of equation. Well, for exponential equations, those methods for quadratic equations don't work. Those methods that we use for linear equations don't work. You need to use methods specific for an exponential equation. Right? So when you're solving equations, the first thing you have to do is recognize what type of equation is this. Is it linear? Is it quadratic? Is it exponential, logarithmic? Is it a trigonometric equation? And what type of equation you have, that will inform what methods you need to use to solve. Right? So here are the methods for solving an exponential equation, which exponential equations are easy to identify because the variable is in an exponent, right? So it's not that hard to figure out, oh, it's 5 raised to an x power. This is an exponential equation. The variable's in the exponent. All right, so the steps we use. First thing, isolate the exponential expression. The base to the power that involves the exponent. Get that base to the power by itself on one side of the equation. Move every other number to the other side, right? By adding, subtracting, multiplying, dividing, whatever you need to do. Clear all the other numbers away. We want one side of the equation to just be the base raised to the exponent. Once we get that exponential expression isolated, then we take a logarithm on both sides of the equation. Right? And when we take the logarithm on both sides, we then bring down the exponent using the law of logarithms that says if I have a log of something raised to a power, I can bring that exponent out to the front. And that's really the key step there to solving an exponential equation. Remember, if you've seen some of the other videos that I did on logarithms and exponentials, they're inverses of each other. Right? So if I have the variable kind of trapped up in the exponent, in order to break it free of being in the exponent, I need to use the inverse of an exponential function, which is a logarithmic function. So I do a logarithm on both sides of the equation. That allows me to bring the exponent down, and now the exponent is out of, or now the variable is out of the exponent, and I can go ahead and do step 3, which is to solve for the variable. Right? So I can't solve for variables when they are trapped in exponents, so I use those logarithms to kind of counteract the exponential stuff and be able to actually solve the equation. Alright, so those are the basic steps for solving an exponential equation. You might want to write them down because they are important, and like I said, every exponential equation can be solved using these steps. Now, some parts might, like step number 1, sometimes you don't have to do step number 1 because the exponential expression is already isolated. Sometimes step number 1 might actually be a 2 or 3 step process. The first move this number, then this number, now this other thing. All right, so each step of the way could be more or less complicated depending on the type of equation you have. But these same 3 basic steps will help you solve any exponential equation. All right, so what I'm going to do here is pause the video and actually erase those steps and then put up an example, and we'll go through these steps to solve an example problem of an exponential equation. All right, here we go with an example problem. We have 3 to the power x plus 2 equals 7. All right, so first thing, like I said a couple minutes ago, identify what type of equation you have. Right here, our variable x is in the exponent of the 3, therefore we have an exponential equation, which means I can't just use the methods. I can't subtract this 2 over here or divide that 3 over like I would with a linear function, because this is not a linear function. It's an exponential function. Right? And a common mistake I see students make sometimes is just not understanding that. Not understanding that the type of function you have determines the methods you need to use in order to solve it. Right? So you can't just subtract the 2, divide the 3, it doesn't work when you have an exponential equation. You'll do some stuff and you'll get an answer, x equals whatever, but it's nowhere near the correct answer, right? So identify the type of equation and use the methods for that. So the method for solving an exponential equation, like we just talked about, first thing is isolate the exponential expression, right? Meaning the base raised to the power. Well, my base is 3, my power is x plus 2, and there's nothing else on that left side of the equation, which means that step 1 is already done for us in this case. Right? I don't have anything else on this side of the equation except the base and the exponent. Right? Now when it says isolate the exponential term, it doesn't mean try to get the 3 to the x by itself. Right? I cannot subtract that 2 to the other side to try to get the x by itself in the exponent. I can't do anything to the terms that are in that exponent when it's in the exponent. Right? I can't touch it at all. I can't do anything with it. So I can't just like start moving that 2 over. That exponent has to stay as a whole. It has to stay all together until I remove it from the exponent. Then I can move that 2 to the other side of the equation and do that type of stuff. All right, so my exponential term is isolated. I should also mention here that really the first thing you should do once you realize you have an exponential equation here is to see if it's one of those simple types. Right? Can I write this? This side is 3 raised to a power. Can I write the 7 as 3 raised to a power? Well, I can't, right? Because 3 to the first power is 3, 3 to the second power is 9. It skips right over 7, right? So I can't do this as like one of those simple equations like I did in that other video, which if you haven't watched, you should. So I can't use that here, which is why I have to do this step-by-step process. Right? So step 1, it's already isolated, the 3 to the power, the exponent. I can't break apart that exponent at all. So step number 1 is done. Step number 2, I take a logarithm on both sides of the equation. All right, now, which logarithm you take as far as what base you use doesn't matter. Right? What I'm going to use is the natural logarithm. Right? And I'll tell you why. Well, there's a couple of reasons why, actually. Right? Now, whatever logarithm you choose to use, you can use a log base 5 on both sides of the equation if you want to. That would be weird and would make more work for you later on. So I would advise you not to do that. I would advise using either the natural logarithm or the common logarithm. And I would strongly recommend using the natural logarithm, the ln, on both sides of the equation. Right? And here's the reason why I would recommend using the natural log. One is because when we get into solving equations that involve models of real-life situations, a lot of those real-life situations use the base e as the exponential function, so e raised to a power. And if you recall from some of the other videos I've done, the e and the natural log will cancel each other out. Right, so when I have equations that involve an e and I put the ln on both sides, the ln just straight away cancels out the e, and I'm like almost done with the problem right there. Right, so that's one reason. Just get used to using the natural log, and then when it comes up with an exponential equation with the e, it actually makes it a lot easier to use the natural log instead of any other ones. Right, the other reason I prefer to use the natural log instead of like the common log or anything else is because when you get to calculus and beyond, the natural log, that's the logarithm that you tend to use most often when you're solving problems in calculus and in precalculus and other types of higher level math as well. So it's a good idea to just start getting used to using that natural logarithm, the ln. All right, so I do the ln on both sides. Remember, as long as I do it on both sides of the equation, it's fine. Right? What you cannot do, don't just put the ln on this side and then forget to put it on the other side. Right? Remember, you're solving an equation, so you have to keep everything balanced. Whatever you do on one side, you do the same thing on the other side. All right, so I do the natural log on both sides. Then I use the law of logarithms, which, again, I did another video on the laws of logarithms. So if you haven't seen that one, check it out. But that says that when I have a log of something raised to a power, I can take that exponent and bring it out to the front. So this is going to be x plus 2 times ln of 3 equals ln of 7. All right, so that's our law of exponents. There were 3 laws of exponents. One of them says the log of something raised to a power, that exponent I can bring out front. Notice I put that x plus 2 in parentheses because still that entire exponent has to stay together as one group. Right, so I put the parentheses around it so I know that this is one solid thing here, this x plus 2. That whole thing is multiplying this ln of 3. Right, if you forget to put the parentheses there, it could mess up the next step of what you do. So you just got to make sure whatever that exponent is, you keep it all together until you get to like the very last step of the problem. All right, so, and this is the reason we do the logarithm on both sides of the equations, specifically so that we can use the law of logarithms to bring down that exponent. Right? Now, my variable, my x, is no longer trapped in the exponent. It's down here on the same level as everything else. So now I can just solve this equation, and I have an x to the first power. So now this becomes basically just a linear equation. Right? I took my exponential equation, put the logs on both sides, brought down the exponent. Now it's just an x to the first power plus 2 times this equals that. And remember, ln of 3, that's just some number, right? ln of 7 is just some number. It's a weird number, but these are just numbers. Right? So you can think of this as like it's 5 times x plus 2 equals 15. Right? It's just, instead of 5 and 15, we have some weirder numbers there. All right? But that's what we got. So now we need to solve this equation for x. And now that the x is out of the exponent and it's an x to the first power, now I use the methods for solving a linear equation. So since it's this whole x plus 2 multiplying this ln of 3, I want to get rid of that ln of 3 by dividing it to the other side. So I'm left over here with x plus 2 equals ln of 7 over ln of 3. And then to solve for x, well, I have x plus 2, so to get the x by itself, I subtract 2. So I end up with x equals ln of 7 divided by ln of 3, and then that whole thing minus 2. Right? This is what we refer to as the exact solution to this equation. Right? Because ln of 7 and ln of 3 are going to be irrational numbers. So if I put these into the calculator, which I will do to get an approximate answer, but if I do that, since those are both going to be irrational numbers, that means I'm going to have to round the answer off. Right? It's not going to give me the exact answer anymore. It's going to be an approximate answer because I have to round it to a certain number of decimal places. So this is the exact answer. X equals ln of 7 divided by ln of 3 minus 2. Right? Notice when I divide the ln 3 to this side, I don't actually combine the 7 and the 3. Right? Natural log of 7 is one single number. Natural log of 3 is another number. Right? This doesn't become the natural log of 7 over 3. Right? It's ln of 7 divided by ln of 3. Right? We don't just combine the stuff inside the logs like that. Right? That's not one of the laws of logarithms or the properties of logarithms. So those two logs have to stay separate. And then when I subtract the 2 to the other side, I don't do 7 minus 2 and make it ln of 5. I don't do 3 minus 2 and make it ln of 1. It's ln of 7 divided by ln of 3. Whatever number I get from doing that, I then subtract 2 from that. Right? So when you're solving these and getting the exact solutions, really, there's not a whole lot you can combine together, right? You have to keep the logs separate. Anything you add, subtract, or multiply or divide, you don't touch the numbers inside the logarithms. Right? Once I do the ln on both sides and I get this ln of 7, that's going to say ln of 7 throughout the whole rest of the problem. Right? Nothing else touches that 7 once it's inside that log function. Same with this ln of 3. Nothing's going to touch that 3 all the way through the problem. All right? So to get the approximate solution here, I almost forgot the word approximate. I do ln of 7 divided by ln of 3 and then minus 2. And notice I close the parentheses after the 7, so my calculator knows it's the natural log of 7, calculate that, then divide by the natural log of 3, calculate that, and then subtract 2, and I get approximately negative 0.228. I don't know, it's hard to read that backwards. Negative 0.22875.6. All right, so x is approximately equal to negative 0.228, let's call it 8 if I round it to 4 decimal places there. It was 875, but that 5 tells me to round that last 7 up to an 8. All right, so depending on what type of problem you're doing and what the instructions are, some instructions say solve this equation, give the exact solution. Exact solution is ln of 7 divided by ln of 3 minus 2. If it says give an approximate solution rounded to 4 decimal places, then x is approximately equal to negative 0.2288. All right, so make sure for these problems you read the directions carefully and give the answer in the proper form. And just one more side note here. If you would use the common log up here instead of the natural log, if you just wrote log 3 equals log 7, well then at the end you would have x equals log 7 divided by log 3 minus 2. If you put that in the calculator, you're going to get the same approximate answer. Right? So like I said, it doesn't matter which log you use on both sides of the equation. But if you plan on going into higher levels of math, I would get used to using that ln, that natural logarithm now, because that's the one you'll be using most often as you move forward. All right, so that's one example of solving an exponential equation. I'm going to do another video where I do a couple more examples that are a little bit more complicated than this first one. So make sure you check out that other video and see some more examples solving these exponential equations.